One of the things that people often get addicted to logic for, or one of the reasons, is that it's so rigorous, so absolutely proven in every step along the way. And there's a certain degree of certainty that follows from that, and so that's nice. However, at times you start, after it's been a while since you've used a rule or learned about the rule, you may question if it really does work. And so while this isn't required to do any of your homework or anything, it's sometimes just nice to reprove to yourself so that you know you're not cheating and nothing is getting away from you, in the sense that you're not absolutely sure that you're using a step that's usable. So, for instance, here this is what was left over when we talked about the constructive dilemma. Sometimes you might not immediately see why it is that constructive dilemma works, and if you ever want to prove it to yourself again, just use truth tables. So in this case, we could just set up the entire argument. We've got P, Q, R, and S. Let's space them out. And we're going to make a truth table out of that. How are we going to do that? We're going to put the first two premises here and the conclusion out at the end. Let me do that real quick. Okay, see what I've done here is I've set up the truth table. I'm using the first three things as premises, and I am listing what you would infer from that as the conclusion. Because here's the question: is this a valid inference? Is this rule valid? Is it the case that when we do have things of this form in the premises of the argument, can we infer in some step, validly, guaranteed, that this would be true? Let's go ahead and fill out the truth table. Okay, now we're back and we filled it out completely. Some of you probably noticed, and well done if you did, that I had not put in the correct inference or conclusion up here. So now I fixed that. And so here's the question. Now that we've got the truth table filled out, assuming I've done it accurately, is it the case that every time these things are true, that this is also true? Let me highlight the cases where the premises are all true. So here now you'll notice that we've highlighted all the instances where the premises are true, or these statements are true. And we've demonstrated that whenever we're given these as true, this must also be true. So in a proof, you're either given these or you've inferred from other rules that these are true. And if something having these forms, some statements having these forms are all found within your proof, you could at any point infer this using the rule constructive dilemma. And now, though this is a longer version, most of them would be shorter than this, we have demonstrated it to be true, and you could rest assured that you're using a rule that works.